Hi, my name is Matt. I want to share with you a nice solution to this related rates problem. I'm going to bring up a slide and go to presentation mode. First order of business is to get a nice diagram labeled with the information we have and some indication of the information we need. The wall is 40 feet high. The tree house is the same height. It's 25 feet from the wall. W will stand for the distance from the shadow to the base of the wall at time t. What do we want to know? We want to know W prime of t at time t equal half. Strategy is to look at the relationship between the shaded triangles. I've got a large one shaded in beige and a smaller one shaded in green. And there are angles at the top of the wall, theta inside the beige one and gamma inside the green one. A bit of a trigonometry review. The tangent of an angle is calculated by the length of the opposite side from the angle over the length of the adjacent side. That's 16 t squared over 25. Looking at the green triangle, 16 t squared is a given in the problem statement. That's the distance of the apple from the treehouse after t seconds. Moving to the larger beige shaded triangle, the cotangent of theta is the adjacent over the opposite, and that's 40 over W of t. Cotangent and tangent, length of opposite and adjacent sides are flipped. That's the difference between cotangent and tangent. Because theta and gamma sum to pi over 2, cotangent theta is equal to tangent of gamma. That's the key insight because it lets us set the two formulas from the previous slide equal to one another. So 16 t squared over 25 equals 40 over W of t. I've copied that forward to the slide I'm on now. I'll solve for W of t, and it turns out to be 125 over 2t squared. I can differentiate that and get minus 125 times t to the minus 3. I'm going to plug in 1/2. 1/2 to the minus third is 8. So multiplying that times the minus 125, we get 1,000 feet per second. Is that plausible? When the apple first leaves the treehouse, the shadow is way, way, way far along the ground. And so it's moving very rapidly toward the wall in the initial stages. So that's why it's so fast. And it'll slow down as the apple gets closer to the ground. The drawing is not to scale, by the way. It's just whatever would fit on the slide. In summary, what did I do? Create a label diagram with the information that's given, give a name to what I'm looking for. If I let the variable W stand for the distance between the shadow and the base of the wall, I can write down, we're looking for W prime of 1/2. This is the first time in memory that I came across a related rate problem where I had to look at two triangles. Usually it was just one triangle, a squared plus b squared equals c squared. Let's say it's a ladder. We're pulling on one end at a constant rate. How fast is the other end moving? In this one, I couldn't find a way to do that. I had to look at both triangles. Once I get those two formulas equal to one another, I can solve for W in terms of t and differentiate. That's my solution.